You know, rocks are a lot like people. They come in all sorts of shapes and sizes, but we really need a way to characterize those rocks and lump them into groups. What we have here are three basic rock types: igneous rocks, sedimentary rocks, and metamorphic rocks. And today I'll talk a little bit more about each. Igneous rocks are the most primitive type of rock. They form deep within the earth from hot molten rock called magma. In order to demonstrate how magma forms, first we need to transition something from a solid state, like this chocolate bar, to a liquid state. In order to do that, we need to heat it up. So what we'll do is take this chocolate out, put it in our pan, and apply some heat. Now that we've added heat to our chocolate, we've changed it into a liquid. And magma changes to a liquid under very intense heat and pressure at depth. What we're going to do is simulate the cooling of magma using this cold ice cream. The ice cream would be the equivalent of the temperature at the surface. The temperature of the surface is not this cold, but compared to the heat of the chocolate, it's not too bad an analogy. And then what we're going to do is we're going to pour this hot chocolate over this cold ice cream, and we're going to do what happens in real life when magma cools. It crystallizes and changes back into a solid. So we have to wait a few minutes. Now that we've had a chance to let our chocolate magma cool a bit, let's take a look and see if we've reverted back to a solid. It looks like we have. So we heat the magma at depth and we bring it up and we cool it. And if we cool it quickly like this, the chocolate actually forms a very fine-grained crystalline solid. If we were to cool it very slowly, in the earth we actually get coarse-grained rocks like granites, where you can see large crystals within the rock. In basalts, like this one from Hawaii, you can see that these cool fairly quickly, so they have a finer grained texture. So as you can see, igneous rocks are pretty cool. Well, after you put them in the refrigerator. If igneous rocks form deep in the earth, sedimentary rocks form right at the surface, as water and air break up pre-existing rock and create sediment. Sedimentary rocks are created from sediment, as well as from biological activity, things like fossils, and from chemical activity in places like lakes, where the water dries up and leaves behind salt or gypsum. These are the sedimentary rocks. And today, we'll really quick make a sedimentary rock. What you need are grains of some pre-existing rock. In this case, we have some rice cereal that serves as our sand grains. I'm going to make sure they're sand, because the word sand means that they're a certain size. Yeah, it's about 2 millimeters or so. It's a little coarse for sand, but it's close enough. Anything bigger than sand would be considered gravel or cobbles in size. And these covered candies here will be our gravel. So as a river comes in and pours this stuff into a basin, and we mix this stuff up, what we end up with is a rock containing many different types of sand and gravel, silt, and clay-sized particles. Those are what we call the clastic sedimentary rocks, and are the majority of the sedimentary rocks that we see around us today. The last group of rocks are called metamorphic rocks. And metamorphic rocks are formed from pre-existing rocks which are altered by high heat and pressure. Usually in the earth, it's from burial deep within the earth. It can also be through volcanics or other ways that we can heat up the rocks to really intense temperatures and then create new minerals and new textures within the rock. So today we're going to attempt to create a new metamorphic rock from our pre-existing rocks here. We've got our bear stone, we've got our wormstone here, and we've got our s'moresite over here, which is a nice combination of marshmallows, chocolate, and graham crackers. Now what we're going to do is we're going to bury these deep within the earth on this plate and create a new rock. We've got this nice hard graham cracker. Got to have a good base for it. A little chocolate. And what we're going to do is we're going to apply heat and we're going to apply pressure. Now, in a kitchen, applying heat and pressure at the same time, it's a little difficult. We could have used a pressure cooker, but you know, well, that wouldn't be that much fun now, would it? So we're going to do it a little more inventive way. And we've layered these rocks like a sedimentary rock, where we have different layers of things on top of each other. And the first thing that we're going to do is we're going to apply some heat. And the way we're going to do that is using the microwave. So let's heat this thing up. See what we're going to get. Now that we've added some heat to our rocks, let's pull it out of the microwave and then add a little pressure. The pressure is an issue. We need to add some pressure. And I think the way that I'm going to do that is I'm going to actually put a little human pressure on this. Put this in place like so. Put this plate up here. I really want to get a lot of pressure on it. And I think I'm a big guy. Well, why don't we do this? Alright. Just going to stand up here and... The more pressure that we add, the more we can deform those different rocks, and now that they're hot, they'll mutate and mix and fold and disfigure themselves into something completely different. Okay, good enough, I guess, for demonstration's sake. Get down here without killing myself. Let's see what we have. Hopefully, something that looks like a gooey metamorphic rock. The gelatin and the corn syrup within the candies is like a lot of minerals that at fairly low temperatures and pressures melt and move around within the rock, almost forming a cement. And if you can see here, we've got the graham cracker, which pretty much stayed the way it was. And now we've got new layers of marshmallow and candy that in a natural metamorphic rock, you can see these folds and gooey shapes. That obviously this rock was under such intense heat and pressure that the rock itself looked something like this. It was a gooey, hot, very big mess is what it was. So metamorphic rocks are interesting in that you can take pretty much anything and make one, as long as you have a lot of heat and or pressure. So today we've looked at the three basic rock types. Igneous rocks, which cool deep within the earth from magma or in volcanoes at the surface. Sedimentary rocks, which form from the erosion of pre-existing rocks and redeposition as sediment, or from biological activity, or from precipitation in water. And metamorphic rocks, the third type, formed from pre-existing igneous, sedimentary, and metamorphic rocks, which are buried deep. Intense heat and pressure causes them to change into a completely new rock. So, guys, thank you, and keep rocking out in your kitchens.